Roots have to do with exponents. And so when we're reviewing exponents, what we have to remember about exponents is that they represent repeated multiplication. For instance, if I asked you for 2 to the third power, what does that mean? If I asked you to expand that. Yeah. Okay. So what we're going to then talk about today is, by the way, 2 times 2 times 2 is 8, right? If I wanted to reverse that process, the reverse of that would be, let's use a different color. I would say that 8 to the 1/3 power, or another way of saying that is the third root of 8, is reversing that process. It's saying what multiplied by itself 3 times gives me 8. So the reverse of that would be 2. Okay. So when I have these written here, these are roots. So at the top is the actual root. And then these are their squares, cubes, fourths, fifths. When we get to fifths, we don't, some of them you want to start to try to recognize, but you can use this as your kind of like your root card that we did in algebra. Okay, so here's how this works. When I'm looking at square roots, I think we probably know this. What's the square root of 36? 6. Why? Because 6 times 6, or 6 squared, is 36. Okay, so let's look at a third root, okay, also called a cubed root. The cubed root of 27 is 3. Why? Because 3 times 3 times 3, or 3 to the third power, is 27. So these are the roots itself are here. Okay, the fourth root of 256. What do you think I mean by fourth root? The fourth root of 256 is 4. Because 4 to the fourth, or 4 times 4 times 4, is 256. Okay. So when we're writing roots, there are a couple ways that there's two, not a couple, means two. There are 2 ways that they're written. I already showed you this. A fraction exponent is referring to a root. So the 1/3 exponent means the cubed root. The 1/4 exponent would be the 4th root. The 1/5 exponent would be the 5th root. Now, can we do roots bigger than that? Yeah, but we don't usually at least recognize roots bigger than that. Okay, so that's why I only put the 5th root on there, not because there's not more than that, but just because we probably don't remember what they are past that point. Some of you probably can say, oh, that makes sense. Yeah, I could do, 2 to the 5th, and it's 32. All right, what if I see them written as this root symbol? Because the root symbol you've learned is square root, right? Okay. What you might see today, and actually we talked about this in Algebra 1, is if it's written like this one, that is a square root. You can put a little 2 there if you want, but that's kind of the most basic square root, okay? Look at this one. This looks like that root symbol, but what do you notice is on the outside of that? That little 3, okay? It's a little 3. It's not 3 times the square root of 8. So when you see this, okay, this tells us this is a cubed root. This is also a cubed root right here. What would this one be? A 4th root. Okay. Now, what I have here are things that are exact, that are all listed up at the top. So we're going to now simplify those things. But I can also show you on your calculator where you can use the calculator keys to find roots for you as well. Okay, so let's just, using these top numbers, what is the square root of 16? 4, right? And below it, this is the answer. I'm going to just write y, because 4 squared equals 16. That's why. Okay, what is the cubed root of 8? Just give me fingers if you want. That way I know you're out there. All right, it is 2. Okay, so I'm looking at my cubed root. I look at the 8. It's 2. The reason why is because 2 to the third equals 8. Okay, I'm just giving you a reason why down here, so understanding what a root is. Now, it's possible you cannot take square roots of negative numbers. It is possible to take cubed roots of negative numbers, because a negative times a negative times a negative is negative. So what do you think the cubed root of negative 27 is? It's negative 3. Why? Because negative 3 to the third, or negative 3 times negative 3 times negative 3, gives us negative 27. And what's the fourth root of 16? Yep, looking up here, the fourth root of 16 is 2, and the reason why is 2 to the fourth equals 16. Okay, so one way that we write these things is as we call that radical notation. That sign is a radical sign. The second way that we can write it is as a rational, what word is in rational? Ratio. So rational exponent. This is also known as a fraction exponent. Okay, a ratio or rational exponent is the same thing as a fraction exponent. Okay, though they are two ways to write them, they mean the same thing. When you're dealing with a rational exponent, I'll talk about first how you just write these things as a rational exponent. But in general, the top number of the fraction is what the exponent is. Okay, so the top number is what we're raising it to. And this bottom number is the root. All right, so these are equivalent things. The top number is the exponent, the bottom number is the root. Here's another one. The way I would write x to the m over n is the m is the exponent, the same as before. The number on top is what you're raising the thing inside there to. And the number on the bottom is the root. Now, by the way, does it matter, because there's two things going on there, does it matter which one you do first? It does not. Sometimes you're going to be able to notice what the root is first, and then you can raise it to the exponent, and sometimes you'll notice what the exponent is first. Those two things can be done in either order. Okay. So, we're just going to practice right now writing as a rational exponent. That's all we're doing. All right, do you remember what I said about this symbol? If there is no little number there, what root is that? Not 1. What's the smallest root up above? A square root. You don't have to write it in, but what that really means is that's a square root. Okay, the way we write a square root as a rational exponent is it is a to the 1/2 power. I already talked about this one again, but if it was a cubed root, it would be a to the 1/3 power. This is where we go real slow. What if you see two things? What if you see a radical and a power? Hello? Yeah. Fine. I'll tell you in a second. All right. So that 5 right there, that's the root. That's going to go, the root is going to go on the bottom of my fraction. And the squared is the power, or the exponent, so that's going to go on the top of my fraction. So the way I can write this as a rational exponent is this is a to the 2/5 power. Okay. Now, remember what I said about this. What root is this? Square root. If you want to write a little 2 there, you can. All right, how would I write this one? A to the, what would the fraction exponent be? 3/2. All right, good. Now, let's do numbers. I'm not asking you to evaluate, guys. I'm just asking us to practice writing as a rational exponent. This is -125 to the what? Write it as a rational exponent. What would the exponent on this one be? Tell me where your 2 is coming from. If I want a number on top, then that's where the top would be. There's no number on top. There's just this. So what would it be, Kayla? 1/3. What about something like this? Well, that's not raised to the exponent. This is -2 times 16. What would be the rational exponent on the 16? 1/4. This would be the opposite of 27 to the what? What do you think, Wendy? So how would I write this cubed root as an exponent? 1/3. And this would be 64 to the 1/3. Okay. Now I want you to try. Would you try to write this first row here? Just rewrite those as rational exponents.